Welcome to Finding Characteristics of Rational Graphs. Let's start. So our essential question is, how do we find the wholes and the asymptotes of a rational function? So remember that a rational function is a polynomial over a polynomial, right? This is where p of x and q of x are polynomials. And the graph of a rational function looks like this, right? It's got these two curves that don't cross. It's different than the other functions we've seen before. And it has these asymptotes, right? Remember, asymptotes are lines that your graph never crosses or touches. So lines your graph never crosses, and it doesn't, or touches, it doesn't touch it either. So if we had a vertical asymptote, right, that one's vertical, there, and a horizontal, because there's two kind of asymptotes, vertical and horizontal, then my graph would be really close to the asymptote line, but it would never cross it. That's why it goes down towards negative infinity, because it doesn't cross this here. And then on this side, it would get really close to the asymptote line, but it would never ever cross it. Now a hole is just like it sounds. It's a jump in the graph. It's just a little hole. So instead of it being continuous, there's just a part in your graph that doesn't exist. Sometimes we draw a little circle to denote the hole. So these are things that can show up on your rational function graph. Asymptote lines, definitely, and then holes. There can be little jumps in your graph. Now let's talk about how to find the asymptotes and the holes on your rational graph. You're giving a rational function, remember it's polynomial over polynomial. The first thing I would do is try to find the horizontal asymptotes. It's the very first thing. And the way you do that is by looking at the degree of each polynomial. Okay, so the degree of this polynomial on the top of this fraction right here is 3. The degree on this bottom polynomial is 4. Okay, so this is a 3, third degree. This is a 4th degree. So the rule is, if the degree is bigger on the bottom, which this is, then your horizontal asymptote is at y equals 0. And one way we kind of look at this, or we can write this, is bigger on bottom 0. So this horizontal asymptote is at y equals 0. Bigger on bottom, then it's 0. Now here's another example. Here's another rational function. Now let's look at the degree of each polynomial. This degree is a third degree. This degree is also a third degree. So the rule, when they're both the same, is that you use their coefficients. So if they're both, BO for both, the same, you use the coefficients. Both same coefficients. So I come back here and I look at the coefficient of where I got the degree from, 6 over 2. So my horizontal asymptote is 6 over 2, which is just 3. So here's the next example, the last rule. I look at the degree. This one's a third degree. This one's a second degree. So in this case, it's bigger on the top, right? So bigger on top, there's no asymptote. All right, so those are the rules for finding a horizontal asymptote. Look for the degree of each polynomial, right? So 3, 4, 3, 3, 3, 2. Bigger on bottom 0. If they're both the same, use the coefficients. So 6 over 2. Bigger on top, no, there is none. There's no asymptote, no horizontal asymptote. Now after you've used those rules to find the horizontal asymptote, then I would go find the holes and the vertical asymptote. So if we're using this example right here to find the horizontal asymptote, remember we look at the degree. So this is a 2, a second degree. This is also a second degree, 2 and 2. So remember, if they're both the same, we use the coefficients. So 3/1. So the horizontal asymptote is at y equals 3/1, which is just 3. Okay, so whenever you're going to look for characteristics of a rational function, find the horizontal asymptote first. Then go find the holes in the vertical asymptote. And that's because what you do to find the holes in vertical asymptote is to factor. Okay, so I would find the horizontal asymptote before you factor. So let's go ahead and factor this here. So my function would turn into 3x plus 1 and x plus 4 over x minus 7 and x plus 4. All right, so the next thing I do, that was that, and then I'm going to simplify, which means, or the other way we say it is cross out or cancel any matching factors. So in this case, I have an x plus 4 and an x plus 4, one on the top, one on the bottom. They simplify to 1. Sometimes we call it crossing them out. So whatever you just crossed out, those are your holes. So holes are whatever you just crossed out. So I crossed out a pair of x plus 4s, so I'm going to take x plus 4, set it equal to 0, and I have that my hole on my graph is at x equals -4. Remember, a hole is like an ordered pair that doesn't exist, so I need to find the y value. So I have a hole at -4 something, and the way you find the y value is you take your x and you go plug it into the x of your function that's left. So I have 3, and instead of x now I plug -4. Instead of x on the bottom I have -4. So that's -12 plus 1, which is -11. -4 minus 7 is -11. So that's -11 over -11 is 1. So I have a hole at -4, 1 on my graph. So I'd go to that ordered pair and that would be where it didn't exist. So that's finding a hole. So now let's look at the vertical asymptote. Whatever's left on the denominator of the function that I just simplified, right? We took out the x plus 4. Now I just have 3x plus 1 over x minus 7. So I take whatever's left on the denominator, and that's my vertical asymptote. So my vertical asymptote is factors that you didn't cross out that are left on the denominator. So I take x minus 7, set it equal to 0, and I have a vertical asymptote at x equals 7. Now this whole thing can be tricky, so make sure you've written notes very well and that you go back and relook at this if you're confused on anything. I've written out the steps here so you can see it. You can write it all down or you can write it out in your own words, but I would make sure you have the steps somewhere. Look at the degree of the polynomial to find your horizontal asymptote. Make sure you remember those rules, right? Bigger on bottom is 0. They're both the same. Use the coefficients. Bigger on top, there is none. Then factor. So you find your horizontal asymptote first, then factor. Simplify or cross out matching factors, and what you crossed out, that's how you get the holes. You set it equal to 0 to find the x value, plug the x back in to find the y value. So remember, holes should be an ordered pair. Then the factors that are left in the denominator are your vertical asymptote. Okay, it's okay to have more than one. Set equal to 0 to find the equation of that line. All right, so let's take an example of a rational function. And let's go ahead and find all these characteristics. So we'll find the holes, the vertical and horizontal asymptote, and then because we already know these things, we're going to find the x-intercept, y-intercept, and domain and range. So we'll start off like we said in the other in the other slide, we want to find the horizontal asymptote first because we just look at the degrees. So this is a degree of 1, this is a degree of 2. So 1, this is 2. So it's bigger on the bottom. So we're going to have a horizontal asymptote at 0, y equals 0. Now I'm going to factor, just like we wrote on that slide with the steps. So here I can factor this, factor the 4 out, get 4x times x plus 3, and then I can factor this to x plus 3 and x minus 2. I can simplify the x plus 3. So remember what I crossed out was my whole. So I had x plus 3, I set it equal to 0. So the x value of my whole, because it's an ordered pair, is negative 3. And then I need to plug the negative 3 back into the x's of what's left. So what I have left is a 4 over an x minus 2. So I'm going to plug negative 3 into this x. And that gives me 4 and negative 5, or negative 4/5. So I have a whole at negative 3, negative 4/5. Now whatever factor is left on the denominator that I did not cross out, that is my vertical asymptote. So what I have left is 4 over x minus 2. So that means x minus 2 is how I get my vertical asymptote. X minus 2 equals 0, x equals 2. So I have a vertical asymptote at x equals 2. Okay, so what I want to do now actually is go, I'm not going to worry about these because we know how to plug in x for, or 0 for x to find our y-intercept and 0 for y to find our x-intercept. I want to find the domain and range, but I also want to actually graph it. So let me graph it first. Okay, so what I do know is that I have my vertical asymptote at x equals 2. So I'm going to go draw that right there. That's about 2, x equals 2. And I have a horizontal asymptote at y equals 0. So that's right on the x-axis line. And then I have a whole at negative 3, 4, negative 3, and then 4 negative fifths. So 1, 2, 3. It's about right there. It's not exact, but that can be what we draw it. So now I know that this is a positive rational function. It's coming from the left. It's going to go along this horizontal asymptote that it doesn't cross, and then it's going to curve down because it can't cross this asymptote either. So let's draw my function. This is the whole where it doesn't exist. And then remember, it gets close to the asymptote, it doesn't actually touch it. So I'm not going to be concerned as exactly which points are here, as long as you can find horizontal, vertical asymptote, and the whole. And in this case, actually you would know there is no x-intercept, right? Because it doesn't cross the x-axis anywhere. We could look on our graph where we could plug in 0 for x to find the y-intercept and see where it crosses the y-axis. But I don't want to focus on that right now. So then my domain is actually going to be negative infinity. But now there's another value we have to, that doesn't exist in the x-axis. This negative 3, it never touches negative 3 because there's a hole. So my domain would be negative infinity to negative 3, negative 3 to 2, and 2 to infinity. Because it comes from the left, nothing exists on negative 3, that's why I have to put this here. And then it keeps going and it can't cross the 2, the vertical asymptote. So that's why that's there. So now it's longer. So the range, kind of the same way. Coming from the bottom, it exists, but it doesn't exist on negative 4/5 because there's a hole there. It can't exist on 0 because there's a horizontal asymptote. So you have to account for all of that. So negative infinity to negative 4/5. It skips that number, can't touch it at all. And then it exists again until 0. And then 0 to infinity. So you'll notice the domain is going to include all the x values, x, the vertical asymptote, and the x value of the whole, right? Because domain are your x values. So the only x's that don't exist are the x value of the whole and the vertical asymptote. Whereas the range is my y values. So the y value of the whole has to be in the range because it doesn't exist, and then the horizontal asymptote because it's y equals. That was a lot. So go back, please, and watch what you need to. We're going to practice this for a couple of days. but make sure that you understand you understand the basics and how to find a hole, a vertical asymptote, and then the horizontal asymptote. Those are the things you need to understand how to find before you come into class. Just the basics about it. You don't have to be great at it. But go study your notes, write your summary, write your questions, and we'll practice it for a few days. Bye.